just change the slide. Okay. So before we start, let me tell you a bit about myself. My name is Marco Russo. I hold a master's degree in translation and interpreting from the University of Salento in Lecce, which is a little town in the south of Italy. I acquired experience as a freelance translator, and then I joined Creative Wars, which is an Italian LSP. There, I first served as an in-house lead linguist, so a traditional linguist role. Then last year, I switched to the role of AI language specialist, which is a role where I combine linguistic expertise with the power of Gen AI technologies. So we start with a quick refresh on what prompts are. Then we'll dive into 5 key areas of advanced prompting, from metacognitive patterns that make AI models think better to perspective enhancement patterns that help generate more nuanced responses. So each section builds on the last, so giving you a comprehensive toolkit for advanced LLM interactions. Let's now quickly align on what we mean by a prompt. A prompt is an input or instruction given to generative AI models, particularly LLMs, to guide their output. So you can think of it as your communication channel with the AI. It can be as simple as a question or as complex as a detailed set of instructions. Every word in your prompt matters because it combines with the model's pre-trained knowledge to shape the output. So it's like having a conversation with a highly knowledgeable assistant who needs the right cues to give you exactly what you're looking for. So I believe you are already familiar with the basics of good prompting, but let's make a quick recap. So an effective prompt should be clear, detailed, and well-structured. You should avoid ambiguity and provide specific context and instructions. Use examples if you want the LLM to precisely follow a certain style or format. If you're not happy with the response, of course, don't give up and use an iterative approach and refine your prompt until you get the desired output. There are easy to remember methods like the create framework that can greatly improve the quality of AI's output. So the create framework is just one of many frameworks you can find online, but you can also come up with your own framework once you have some experience. So let's now go beyond basics. As I said, you've likely mastered the basic prompting strategies, but there's a whole world beyond that. In this presentation, you'll learn more about lesser-known techniques that help you interact with language models like ChatGPT to get optimal results. Those advanced methods unlock more control, precision, and creativity when using LLMs for a variety of tasks such as generating content, problem solving, brainstorming, or automating workflows. So these techniques go beyond the standard prompting practices as they offer you ways to get more precise and reliable outputs. And they also allow you to let the LLM use better reasoning techniques. And also you can use these techniques to reverse the role of the person that is asking and the LLM that is responding. So you have alternative interaction patterns. And then we also have thought process manipulation. We see them in more detail later. So let's start with something powerful, the metacognitive patterns. These are techniques that essentially make the AI model think about its own thinking. The simplest version is the explain your thinking approach. So this approach helps avoid overly brief or shallow responses. and instead leads to more detailed and logical explanations. The prompt includes requests like explain how you arrived at the conclusion or break down your reasoning. This encourages the model to walk through its logic, making the thought process more transparent. In this way, the model is more likely to follow a structure that resembles human logical reasoning, which can involve laying out facts, assumptions, intermediate steps, and conclusions. And you can also, by using this technique, reduce errors by forcing the model to articulate its reasoning. A key benefit is that the likelihood of errors decreases. If a mistake is made in one part of the reasoning, it becomes easier to spot, both for the model during its generation and for the user when reading the response. And chain of thought is another technique that takes this even further. Is a technique that encourages LLMs to break down their reasoning process into explicit steps rather than jumping directly to conclusions. The key is prompting the model to think aloud as it works through a problem or analysis. So, what sets chain of thought apart from simply asking for explanations, as we did before, is that it mimics the natural human cognitive process of working through a problem step by step. So, by doing so, it not only leads to more accurate results, but also makes the model's reasoning transparent and verifiable. It often helps the model to catch its own mistakes and arrive at better conclusions, just like how we sometimes catch our own errors when explaining something to someone else. So let's see now the chain of thought in action. Here you see an example. We asked to calculate the final cost of a jacket considering a discount, sales tax, and a store credit. So notice how the model broke down the problem into logical steps. Oh, sorry. And it showed each calculation and built each step on the previous results and made the reasoning process transparent and verifiable. And this is much more useful than just saying the final cost is 131.90, because you can check each step for accuracy. You can identify where any errors might occur, and it helps verify that all factors were considered. Let's see now the cognitive verifier pattern. It encouraged the LLM to consistently break down questions to enhance the accuracy and relevance of its answers, especially when dealing with complex or broad questions. So the essence of this pattern is to break an initial, often vague query into smaller, more manageable sub-questions. So by addressing each of these sub-questions, the LLM can combine the answers to deliver a more comprehensive response to the original query. So this pattern is particularly useful for tasks that require logical sequencing, brainstorming, or organizing narratives. So by breaking down the problem step by step, the LLM can generate more refined and tailored outputs that are better suited to the user's needs. This is also useful when you don't know exactly how to address a specific problem or topic. So you can start with a broad generic question and then let the LLM guide you with follow-up questions. Let's now see an example of this pattern. So this example shows how from a broad questions, we managed to get a fairly accurate response thanks to the follow-up questions provided by the LLM. So this is particularly valuable when accuracy is crucial, like in technical documentation or data analysis. So we asked, how can I use AI for terminology extraction? Then the LLM provided us with three additional questions. And it also said, once you answer this, I can provide a tailored solution for AI terminology extraction. So on the right, you can see that we answered the 3 questions, and then we receive a fairly detailed response. So as I said before, this is it is good when you are not an expert in a specific field, so on a specific topic, and you can start with a really broad question and let the LLM help you to get more detailed responses. Let's now move on to interaction modification patterns. And these are ways to change the typical question-answer dynamic with LLMs. See, these patterns are about breaking out of the conventional interaction model to get more interesting and often more accurate results. The first pattern of this kind is the ask me questions before you answer, and is a strategy designed to encourage AI systems to seek clarifications before generating a response. And instead of immediately providing an answer, the system asks follow-up questions to better understand the user intent, ensuring the response is more relevant and accurate. So this technique is particularly useful when the user input is vague or ambiguous. If a prompt could be interpreted in multiple ways, asking clarifying questions helps narrow down the focus. And it's also useful when you have complex prompts for questions that may require detailed responses. Breaking down the request through questions ensures that each aspect is covered comprehensively. And it is also good for establishing context. This technique is helpful when context is lacking or where additional background information would improve the quality of the response. So in the example, you can see I asked for advice on improving my team's productivity. So I started with a broad request. And I said, ask me questions before you answer. Here we can see that the LLM came up with 8 additional questions that could help to get better results. And by asking these clarifying questions, the AI ensures it has the necessary context to provide more relevant, actionable advice. Let's now see the flipped interaction pattern. This is an approach where the typical interaction between the user and the LLM is reversed. So instead of the user asking questions and the model responding, the model takes the role of the interviewer, asking the user questions to gather information and achieve specific goals faster and more accurately. This is similar to the ask me questions. We ask me questions before you answer that we saw before, but the difference is that here the focus is on the goal you want to achieve, which should be clearly stated at the beginning. So this is a good approach when you have a clear goal in mind. By adopting this interaction pattern, the model can guide the conversation towards a specific goal, such as solving a problem or explaining a complex concept. This pattern is particularly beneficial when the user may not be aware of all the relevant factors or data related to a specific topic, allowing the LLM to fill in the gaps through its questioning process. So as you can see, typical phrases are, I would like you to ask me questions to achieve X. You should ask questions until the condition is met or to achieve this goal. And ask me questions one at a time, two at a time, etc. You can choose. So let's see an example of this pattern. I would like you to ask me questions to achieve the following goal. Writing an article about AI in localization. You should ask questions until this goal is achieved. Ask me the questions 3 at a time. So maybe when you don't immediately have the answer to all of the questions, the LLM also implicitly suggests which researches you should do to write the article. So this is a perfect example of a good human AI interaction, because um, it doesn't just give you information. It also is implicitly prompting you to do some more research and then come back and give the new information you have. This one is interesting, act unlike a typical AI. When prompted this way, the AI can move past basic algorithmic reasoning and offer responses that are more creative, insightful, and perhaps even surprising. So it's in these non-obvious and atypical answers that the most original ideas and solutions often emerge, allowing users to exploit the true potential of AI as a creative partner. So let's see an example of this pattern. I want you to briefly describe what a sunset looks like, but avoid any common descriptions or cliches like beautiful colors or the sky turning orange. Act unlike a typical AI and give me a fresh, unexpected take that feels original and surprising. So, as you can see, the response we received is really different from the common and basic description of a sunset. So we have, as the sun dips toward the horizon, it feels as if the day is exhaling, releasing a long held breath. So as you can see, this is really creative and even surprising. Of course, if you don't like it, you can still refine your prompt or asking to change some bits, but still is a good base from where you can start. You can even take in and edit it manually yourself. Okay, now let's move on to structural enhancement patterns. These patterns are about organizing information in ways that make the AI's responses more powerful and flexible. Think of it as creating a better framework for the AI to work within. So the first example of this kind of patterns is variables. And variables are placeholders that you can replace to create different versions of the same prompt. They usually are words or phrases enclosed in special characters, for example, in braces. And this approach is particularly beneficial in scenarios involving multiple inputs, repetitive tasks, or varying data, as it allows for more scalable and adaptable interactions with LLM. So consider a prompt with variables as a template that you can use over and over. Um, Variables have three key benefits. The first is efficiency. They allow users to create templates, saving time when creating multiple prompts with just slight variations. So instead of rewriting the entire prompt for each new case, you simply replace the variables with new values, streamlining the process. For example, you could use the same prompt structure for creating content across different languages or markets just by changing the language and local variables. The second benefit is consistency in output, and variables ensure that the code structure of the prompt remains consistent even when some of its elements change. This leads to more reliable and uniform results, as the prompt logic doesn't vary across different instances. So this is particularly valuable in professional settings where maintaining a consistent voice or format across multiple pieces of content is crucial. Imagine, for example, creating product descriptions for hundreds of items, and using variables ensures that they all have the same structure and quality. The third benefit is scalability. Once you have created a solid variable-based prompt, you can easily scale your content creation process. You could even automate the process by feeding different values into your variables from a spreadsheet or a database. Let's see a practical example of how to use variables in prompts. Here, I created a flexible, really basic template for content creation. And as you can see, the variables are highlighted in red and are enclosed in braces. And after placing them in the prompt, which is the upper part you can see in the slide, you write them again under the prompt and assign to each of them a value. So in this case, we have content type, topic, tone, audience type, format, and extra. Just remember that you have to provide the LLM with both the parts you see here. So the actual request, that is the upper part, and then the variable list at the end with their assigned values. So by changing these values, in this case, you can quickly generate different outputs while maintaining consistent quality. So this is a real-time saver if you plan to generate multiple content types with the same prompt structure. And also, if you think about what we were saying about scalability, if you link this with a spreadsheet or database and you map the variables with the columns you have in the spreadsheet, it becomes a really powerful tool for batch processes. So let's now move to the follow the pattern, also called few shot prompting. This technique is about showing rather than telling. It involves structuring prompts in a way that the model is encouraged to continue a text or complete a task by recognizing and extending a pattern established in the prompt. It's like training the AI through demonstration rather than through explicit instructions. This technique leverages the model's ability to predict sequences based on context and previously seen examples. The pattern can be in the form of text, question-answer pairs, or any structured format. It should be generic enough that the model can apply it to new examples, allowing it to recognize similar structures and extend them appropriately. The clearer and more consistent the pattern is, the more likely the model will follow it. So this technique is useful when you want predictable, consistent output from LLMs, especially in situations where the model might otherwise generate creative but unwanted completions. By giving it a clear template to mimic, the model is more likely to meet your expectations. So as you can see in the slide, we have this example where we gave it an input sentence and then a sentiment. And after giving it 5 examples, we then provided only the input sentence, and then it replied with the sentiment. Let's see another technique, which is a chain of density pattern. This is a technique where you progressively increase the information density of a piece of text while approximately maintaining its length. So think of it as a progressive refinement where each iteration adds more depth without bloating the content. This is particularly valuable when writing executive summaries, when creating impactful abstracts, and when crafting social media content with character limits. So as you can see in the example, we asked first to write a basic paragraph about AI in healthcare. Then we said rewrite the paragraph with more specific information while keeping the same length. Then we specified something else. We said add precise data and statistics while maintaining the same paragraph length. And then finally, we said add technical details and specific examples while keeping the same paragraph structure and length. So let's see what the result would be. As you can see, the LLM progressively added more information based on our requests, but somehow managed to compress everything into a dense paragraph that is still short enough to be read quickly. So you can see that the final version is of course a bit longer of the compared to the first version, but it's still short enough to be read quickly, right? So let's now move to another type of pattern, the iterative improvement patterns. These are techniques that refine the outputs through multiple steps. So instead of trying to get the perfect response in one go, we use a series of improvements to reach the desired result. The first pattern of this kind is the iterative prompt refinement. So this approach involves offering an improved or more specific version of a user questions. So helping the user to write a more thoughtful and focused question. So the system responds to simple questions with enhanced versions, encouraging more depth and clarity. So as you can see, the typical phrase you can use is from now on in this conversation, whenever I ask a question, suggest a better question and always ask me if I would like to use it instead. So this is about fine-tuning your prompts based on the responses you get. So, sorry. Each iteration helps you understand how to better communicate with the model to get closer to your desired outcome. So it's like having a dialogue where each exchange helps you refine your communication to get better results. Let's see another pattern. This is called instructional chaining. Is a prompting technique where you break down a complex task into a sequence of smaller connected instruction that build upon each other. So it's different from the chain of thought we have seen before, because you explicitly define the sequence of steps you want the model to follow, rather than asking it to show its reasoning process. So you are guiding its reasoning process more than the chain of thought we've seen before. So let's see an example here. We asked, take this customer review. The interface is confusing and slow, but customer service was helpful. Then we asked first to identify the key positive and negative aspects, and for each aspect, suggest one specific improvement, and use these improvements to write a product team memo. And finally, draft a response to the customer based on the planned improvements. So instead, leaving it to the LLM to decide which steps it should use in its reasoning, we laid out the steps ourselves. So this is particularly valuable when handling complex tasks that require multiple transformations of data or content, when creating outputs that need to build upon previous results, and for ensuring a specific sequence of analysis or processing, and to maintain control over the analysis process. Let's see another kind of pattern. I think it's the last one. The perspective enhancement patterns. So these patterns help generate more balanced and thoughtful responses by deliberately introducing different viewpoints into the conversation. So one type of this pattern is the devil's advocate pattern. And we will examine only this technique for this section. This is a sophisticated prompting technique that leverages an LLM's ability to examine multiple perspectives by challenging its own conclusions. So this pattern improves the quality of analysis and helps identify potential weaknesses in reasoning. It proves particularly useful when working on complex decisions or analysis, where blind spots or biases could have significant consequences. This technique really shines in strategic planning, policy development, risk assessment, and academic research, where challenging assumptions and identifying potential flaws can prevent costly mistakes. This pattern helps overcome the common tendency of LLMs to be overly agreeable or one-sided in their responses, forcing them to engage in more rigorous critical thinking and produce more nuanced and well-rounded analysis. So whether you are writing a crucial proposal or developing a controversial policy or making a major business decision, this technique helps uncover hidden pitfalls and strengthens your final conclusions by subjecting them to systematic and structured criticism. So let's see an example of this pattern. Uh, it shows how we can take a topic like the 4-day work week and examine it from multiple angles to arrive at a more nuanced understanding. So you can see that in the initial prompt, we asked, what are the benefits of implementing a 4-day week? A 4-day work week. So that the devil's advocate version will be now, as the devil's advocate, what are the strongest arguments against everything you just said about the 4-day work week? Be as critical and thorough as possible. Then we provide a third prompt when we say, given both perspectives, what's a more nuanced and balanced view of the 4-day work week? So as you can see, this is not a single prompt, but it's actually an iterative process when we provide the initial prompt and then the devil's advocate prompt and the synthesis prompt. And this pattern can have some variations. For example, we can use the multi-perspective devil's advocate, where in this example, we ask to challenge your conclusion from 3 different perspectives: financial feasibility, practical implementation, and long-term sustainability. So you see, we are already introducing the different viewpoints we want the LLM to analyze. And the other variation is stakeholder-based opposition. Now critique your answer from the perspective of an experienced industry veteran, a skeptical investor, and a concerned employee. So instead of leaving the LLM the freedom to explore other viewpoints, here we are specifying which perspective it should take into account, specifying the stakeholder in the matter. So this brings me to the end of my presentation. So we looked at a toolkit of advanced prompting techniques that can help you get more sophisticated and nuanced responses from LLMs. So I encourage you to experiment with these techniques and find combinations that work best for your specific needs. And thank you all for your attention, and of course, happy prompting. And feel free to ask any questions if you have.
Thank you very much, Marco. I'd like to ask you one question, if it's okay. Where did you learn all that?
Well, it actually takes some research, and some techniques you learn them with the practice. So you instinctively learn that after making a lot of tests with prompting, you kind of get to understand how the LLMs do their reasoning. But a lot of the techniques I showed you can be searched online, and they can even be asked to the LLM itself. If you ask GTP or Claude or Gemini to suggest you more advanced prompting techniques, it will of course help you and suggest similar techniques to the one I showed you. So yes, there actually online there is a lot of materials, a lot of articles you can read about this topic. I'll check the chat for more questions. Okay. So how did you arrive to all these conclusions while working with AI? So of course, as I said, some things you learn from practicing. So if you try with one type of prompt and it doesn't work, you try something else. So some of them you can learn just testing and testing the LLMs until you get the result that you want. So when you get the perfect result, you say, "Oh, now this is what works." So you remember that and you learned it. But as I said, there is really lot of materials online, and even free materials, not necessarily paid courses. So you can feel free to check, because I showed you only some techniques, but there are a lot more. And the more people works with LLMs, the higher the number of techniques that they will discover. As you can see, it's nothing complicated. It is nothing about IT or really technical stuff. It just takes a bit of creativity, I think, and it's a bit like it's not that different compare when talking to a human, right? So when you want to get something specific when talking to a person, sometimes you have to be creative. So it's kind of the same process, but of course the LLMs have their own processes and their own reasoning. So my suggestion is look online for all the documentation you can find about this, and then experiment yourself until you find what works best for you. Let's see something else. Are these patterns applicable to all kinds of AI? The answer is no. They are specifically targeted at LLMs. So they are targeted to this special type of artificial intelligence that is specialized in understanding natural language and generating human-like text. Acts unlike a typical AI, allows AI to use temperature one, or are they two different things? Well, they are two different things, because the temperature is a parameter you can set when prompting an LLM, and the higher the number of the temperature, the more creative the output will be. But it's a bit different, because is a more dangerous way of obtaining creative outputs. If you try to put the temperature over one, you can see that you receive sometimes really crazy results. Sometimes it's even gibberish. I mean, things that you can even understand what the DLLM is saying. So my advice is play with the prompts, but be careful with the temperature. I noticed that actually what I did more often with temperature is setting it lower than one, because you get more consistency. With temperature from one and up, you have less consistency, and of course you have more creativity, but it becomes more unstable and more unpredictable. So of course it depends on what you're looking for, but also in this case you should feel free to experiment and explore these techniques and these settings, like the temperature settings, and see what results you get. Oh, this is a nice question. It would be interesting to hear, as an example, if, how, and when you used AI to prepare this session. I used AI a lot to prepare this session, and I used it to receive ideas at first. So to receive ideas about what topic should I cover in my presentation. So even before having this list of techniques, when I only had the title of the presentation, I asked GPT, and not only GPT, I asked GPT and Claude, which is Anthropic's LLM, and I asked for ideas. So basically, I did brainstorming with the LLMs. So I checked the ideas that they proposed, and I filtered them. I took the ones that I thought they were more interesting, and I left out those that were less interesting. And then I also used it, for example, to group the different techniques in the different categories, because at the beginning my presentation was just a list of all these techniques, but then I wanted to find those that had something in common, so I could put them in a category. And I asked the AI to help me with this. And in general, I use it a lot for content creation. Like in this case, I even asked me to suggest a script to follow when giving the presentation. So yes, I think it's a great tool for this kind of tasks. How do you fact check the answers it generates? Do you just Google every single piece of information and data it mentioned? What are the best use cases in your experience? So you have to check, of course, but in this case, I felt that I could use AI to help me create my presentation, because I was going to write and to talk about a topic I already know. So if you already have knowledge about something, it's really easy to fact check the answers to verify that they are correct. But of course, while creating this presentation, sometimes I happened to have some doubts. So I made some searches to be sure that what the AI was telling me was correct. And in this case, it actually was. So I didn't find any serious hallucination. But when you are dealing with a topic that you don't know well, yes, you need to check a lot more. So of course you can also use your instinct, because sometimes you immediately know when something is off, something is sounds strange. But of course you have to verify through your own searches. But nonetheless, this is still a great tool that allows you to save a lot of time when creating context of this type. Or even if you really don't want to trust the AI in this sense, you could use it only for having idea suggestions for brainstorming, like I did at the beginning of when I was creating my presentation, right? Because I first asked just for ideas, just for brainstorming about what could be the topics that I could include in the presentation. So in that case, I had nothing to check because they were just ideas. And if you feel that you don't want to trust the AI in asking to write actual content, then you can just use it to brainstorming. You can use it as an assistant. You can use it to summarize a long test into a few sentences. And then, of course, you read those sentences, because always remember that this is a tool. Uh, it's not something that allows you not to work, right? I mean, you still have work to do. You still things to do. You just do it with a tool, a new tool that assists you and helps you and allows you to save time. So I see a similar question. How much of this presentation was created using an LLM? If we want to learn new patterns, can you suggest a course we could take? Well, I don't have a specific course in mind, but you can look for them online. But as I said, there are so many free resources that I think they are enough. And especially because, like I said before, prompting is something that has a lot to do with practice. So I think you should practice and practice again over and over and make tests, experiment. And when you do this, you gradually come to understand how an LLM works. And of course, before going straight to look for courses on prompting, something really useful is taking some courses that explain what LLMs are and how they work. One example is that a lot of people don't know that LLMs cannot count, cannot calculate. They think that since they are a type of artificial intelligence, oh, they must be great at math, they must be great at calculating things. But this is not true, because LLMs are models that just predict the most likely words that come next in a sequence. So they are basically they function with statistical models. So they cannot count. If you ask an LLM to make a 2 plus 2, of course the LLM will say that the result is 4, but will say it not because it calculated it, but it will say the result is 4 because of statistics, because statistically in the data that it was trained with, he finds that the answer is 4. So if you give an LLM a complex equation, he is still able to give you the correct result, but not by calculating. It will make an API call to a language, a programming language. So, for example, it will use Python to solve a complex equation.